Uh, Good morning. The I'm currently the chair of 376, and I'm going to cover We're in the process of finishing up with the second edition of 376, which is a code. So my presentation is going to have three parts to it. How we got through the first edition, changes in the second, and where we think we're going in the future. So it all begins with a letter from NFPA to actually it's the NFPA 59A committee chair, the ACI, asking that ACI prepare. Actually, they asked for a specification which fits into the category of a code for ACI to cover all things concrete to do with LNG. And the reason for that is because they didn't consider themselves to be expert on the topic and didn't want to be the referee for changes to what they've got in 59A. So the first organization meeting was in 2004. It was standing room only, including a funeral director who was interested in cryogenics. I didn't see him after that, but the committee was formed by Nick Legatos, and then followed with Nevin Kristolovic. And from 2004 to 2010, we went through 9 different drafts and finally published a provisional document in 2010. And the officially what's out there now is the 2011 edition, which was actually published in 2013. So having said all that, what's RLG anyway? Well, they're gases that are liquid when refrigerated, and in today's world, they're stored typically under an internal pressure of something less than 5 psi. They consist of natural gas and the natural gas liquids that come out of that are found with natural gas, and so that breaks down into liquefied natural gas, which is mostly methane. That's how it's stored. And then the other major products that come out of natural gas are LPG, which is mostly propane, and the other one is butane. And what you'll see is if you, it's not uncommon to have LPG and butane storage associated with the LNG. And we did a project in the early 1990s where the environmental folk regulators said that you can no longer flare the propane and the butane and either put it back in the ground or store it. So they opted to store it. The other thing I've included with this is the storage temperatures. So LNG is minus 260. And the LPG and the propane butane that go with it are basically around minus 50 degrees Fahrenheit for propane, and it's right around freezing for the butane gases. So and then if you look at the natural gas liquids that are associated with natural gas, from natural gas, they use those as feedstocks for making anhydrous ammonia and ethylene. And the other category is the liquid oxygen and liquid nitrogen that comes from air separation plants, and these are used in all sorts of commercial and medical purposes. And what I've done is I've included the chemical symbol for all these things, and you'll notice that everything that we turn into refrigerated liquids comes from hydrocarbons, and then the linen LOX tanks are obviously from air, which is basically nitrogen and oxygen. So very cold temperatures for the air the air feedstocks, and the only other one that's at a cold temperature from the hydrocarbons is the LNG, which is stored at minus 260. And the other one that's fairly cold from that is minus 55. The others are at fairly warm temperatures, which creates basically two different designs that you have to deal with, which are the very cold ones that in the old terminology, we call them cryogenics, and the warmer ones got the nomenclature of low temperature. So and the ACI 376, the purpose was basically to provide a code for concrete primary and secondary containment for the RLGs, meet the regulatory requirements, and also for standards writing organizations, and to be a reference document for project specifications. Okay, so specifically, it was to address the original request from NFPA 59A that they could use 376 as a reference document. Yeah, the other people, our other target audiences are the regulatory bodies, and which are basically two of them. I'll start with FERC, the Federal Regulatory Commission, and they're basically about licensing and siting, and they have a whole list of things that they go through. And there's only one that affects us directly, and that's the assessing the suitability of the system being used. The other one is PHMSA, which is the Pipeline and Hazardous Materials Administration, and their function is basically to set standards and enforcement. And anything that is hooked up to a pipeline, they have jurisdiction over. And for all practical purposes, you'll have to satisfy their requirements for any kind of RLG storage in one fashion or another. So currently, ACI staff is working with the committee to petition PHMSA to amend the current regulations that don't include reference to ACI 376. And so that is ongoing, and I believe there's actually a meeting today on that topic. Configurations. We basically have four different types of storage configurations. One is what's called single containment. You have a single container, and it's usually surrounded by an earthen dike or some sort of a bund wall that is at some distance from the container. This is a single structural system. The next category is this single system enhanced by some sort of a secondary container that is also a structural system, usually close in within about 3 feet or a meter. And then we get in, and that would be the secondary container is open to the atmosphere. And then the third category is the full containment, which in its modern version for LNG typically is an open top primary container that is enclosed by a secondary container with a roof and that contains the vapor pressure. This has two structural systems. So throughout all these discussions, where you're always looking at, do you have just a single structural system or do you have two structural systems? So, and the fourth category, which I haven't listed here yet because it doesn't show up in 37611, is the membrane tank, which is a single structural system, but has two containment systems. A membrane stainless steel liner for the primary container, and then the actual concrete, pre-stressed concrete container is the secondary container. But as a structural system, that the pre-stressed concrete serves both functions. Okay. And one final thing, for the warmer RLG liquids, typically above minus 50 degrees Fahrenheit, minus 45 C, they tend to be single wall tanks with external insulation, unless you're using a full containment system, and then they're similar to the colder products. And the 376 is basically written around the full containment system, and these tend to be used. You'll find them in almost all import-export facilities that are being built these days. Not everyone does it, but the reason for using the full containment system is you can get more containers in a given space. If you look at this, so here's an open top tank. It's designed to carry the product load. Okay, it's topped with a suspended deck which has insulation. The primary function of containment of an RLG container is you'll find that the entire space needs to be encapsulated by insulation. So you have the roof insulation, the wall insulation, bottom insulation, which is this will in a full containment will typically be perlite, loose fill. This will be load-bearing foam glass blocks, and the roof insulation is typically fiberglass. So if you look at this primary container, most of the ones that have been built have been steel. We'll get into the concrete ones a little bit later, but if you look at this, you have a lot of single containment tanks that have been built with a dike around them had a steel tank, open top like this with the roof. Okay, then they had a steel outer container that went all the way around, carbon steel, and it was the vapor container and also the weather shield and the insulation container. Okay, if you take that all steel tank and put the pre-stressed concrete wall around it, concrete roof, and provide some sort of a secondary bottom and a concrete floor of some sort. This one shows a pile cap. You get the full containment system. One thing the code does not address is all the hardware that goes up on the roof of an LNG tank. We don't address that directly. Let me move on to the next one. Oh, and one thing I want to point out is quite a few import-export facilities were built in the early 90s, and they tended to be 160,000 cubic meters. And that represents it matches the LNG ship carrier capacity of the time. They're going up over 200,000 cubic meters. So you try to match the tank capacity with the ship capacity. Peak shaving plants, which are used to supplement the pipeline gas, tend to be around 25,000 cubic meters. The fundamental detail of again, this is the full containment system. All right, they tend to be built with a monolithic joint at the foundation to the wall, pre-stressed vertically and also horizontally. This creates a problem for two things: mechanical load for the thermal loads. When you have a spill, the assumption is that your primary container has been compromised, possibly by an earthquake, and a maximum earthquake event, and that you get a slow spill into the annular space. And because of the minus 260 degree Fahrenheit liquid impinging essentially an ambient temperature wall, because this is loose fill insulation, provide a corner protection here that is of suitable material for for LNG. It's 9 nickel, and you anchor it into the wall. The top detail has to do primarily with supporting the roof. So if you're designing one of these, it's generally pretty simple. You spend a little bit of time coming up with the basic cross section, then you spend the next 6 months working with the boundary conditions. And I'll continue on with the thermal corner protection. One thing we did, this is new for the second edition. We went through and provided details for executing the corner protection that would be considered suitable. And we have 4 different flavors of it. I won't go into the details, but they basically get into addressing the region above the thermal corner protection. This would be 9 nickel steel for an LNG tank. Everything below here would be, this would be the insulation space to keep this space warm. And it's all about anchorage and preventing leakage of coming behind this embedment, because this is typically carbon steel above the thermal corner protection, and it's not suitable for exposure to LNG. You can expect it to crack if it gets that cold, and so the assumption is that the liner will not be effective in a spill event. So we came up with 4 different flavors of it, and I won't go through that here, but that's what they look like. So that's new. The double containment, this is basically you have a freestanding tank. It'd be a single wall if it's propane, butane, probably with external insulation. If it's LNG, this would be the insulated carbon steel outer tank. Appropriate steel for LNG would be 9 nickel. And you have a close-in bund wall with some sort of weathered shield, and it's open to the atmosphere. 1 structural system, 2 structural systems in the event of a spill. All right. The example here is this is for ethylene. It's the first bund wall I ever designed, and here's the particulars of it. It designed for ethylene, and it looks just like this. And it's pre-stressed vertically and horizontally. We'll jump to the next one. Here's an example of a propane tank, and just to give you an idea of what they look like, this particular one is under construction. The tank's being built, hasn't been insulated. All this white stuff on the roof is sandblasting sand. Excuse me, from the painters getting ready to paint or prep it for painting and insulation. 40 meters in diameter, about 131 feet, 16 inches thick, 400 millimeters, and pre-stressed vertically and horizontally, and built with a jump form system. Here's the true structural system. Let me back up. Primary tank contains the liquid. In the event of a spill, you have the secondary container acting as a structural system to contain the liquid. The advantage is you have a very small. Here's some more examples. The one thing I want. Let me jump to the end of this then. And for anyone interested in this, the slides are available. Here's what we did for the second edition. Basically, we took up all the future action items from the previous edition. We added the membrane tank, and and lots of updates. So what the document outline is unchanged. Here's a list of the things we went through, and here's the membrane tank, which is very similar to that, and the details there. So where we're going in the future with this is we expect to be done early spring with a second edition. And for the third edition, we're going to integrate Appendix D into the main body and change the format to ACI 318, terse language, lots of lists and tables. And then looking at possibly a reference standard that would address usage outside the USA.